Hi, in today's video, we're going to talk about dummy variable regression in detail, the mechanics of estimating one, or estimating a model with dummy variables are already detailed in the previous video, and the mechanics on how to write the code in both theta and R is already discussed in that earlier video. Now, in today's session, we're just going to do a quick discussion of what it means to have a model with the dummy variables, how to interpret those results, and what are the uses basically of qualitative or categorical dummy variables in your regression models. Now, there are two ways to see dummy variables, right? To use dummy variables. Number one, you can include the dummy variable in your model if you believe that the average of your outcome variable differs between two groups, right? So that's what we call the shifter. Basically, after controlling for all other regressors or for all other factors in your model, you have a sufficient reason, you have a conceptual framework to believe that your average, the average of your outcome variable differs between two groups. So we have a shifter. The second purpose of a dummy variable is to use it as a slope changer. Basically, you're saying, or you have a reason, sufficient reason to believe that the effect of one regressor varies between two groups, right? So we're going to discuss that in detail. We're going to demonstrate how to interpret those results, and we're going to see it visually using a plot. Now, in this session, I'm just going to use stata since the mechanics for estimating models with dummy variables are already discussed in the earlier video, which I will share in the link down below. Right, so as you can see, I already have a code or a do file prepared for this exercise. Since, again, the mechanics are already there, this is just a matter of discussing the results if you try to include a dummy variable in your regression model. So for this exercise, let's use wage one data. And so let me just run this. And let's make the model simple. So suppose you wanted to estimate a wage model with experience, right? But you have a sufficient reason to believe, or you have your you have your theory, you have your hypothesis that the average wage after controlling for experience varies between two groups, between males and females. So to account for that difference between two groups, you'll have to include the dummy variable for male and female. So in this case, we already have a dummy variable for the gender, for the sex of the respondent, right? To do a quick check, let's try to run a frequency table. So here we have an identifier. You have a dummy variable for the sex of the respondent. So you have 0 for male and 1 for female. Okay. Now, if your variable is already encoded in this manner, you can just plug it in, right? You can just plug the variable in your regression syntax, right? In your regression command. But uh, to be safe and to make sure that you know that the variables that you're including in the model are categorical or factor variables, or in this case a dummy variable, it helps to use the factor variable indicator I dot, right? We already have that in the previous video. Okay, so let's try to estimate this. Let's assume that the standard errors are let's assume robust standard errors for this exercise. Well, we're going to assume heteroscedasticity in this case. So let me run this model. All right. So here's the result. So what does this mean, right? So this regression, the results of this regression implies that your average wage, or average L wage to be exact, differs between males and females after controlling for experience. This means that on average, after controlling for work experience, remember that when you include a regressor in your model, you're practically filtering out the effect or the correlation of that regressor with your variable of interest. So if the variable of interest here is female, this means that after controlling for experience, there's evidence to say, and given its statistical significance, there's evidence to say that females earn significantly lower wages on average than males. So notice the negative sign, right? So what does this imply exactly? So this means that at the baseline when female is zero, so this is a variable. This is your dummy variable. If female is zero, if all respondents were male, their average wage would be at 1.75. Right? Log wage, the average log wage would be 1.75. But if the respondent is female, right, that average, which is 1.75, would be deducted by this coefficient estimate, which is 1.39. So it just means that when the respondent is female, they earn significantly lower wages on average, and the difference would be at around 0.39. So this 0.39 measures the difference between the two groups, right? The intercept measures the average for the base group, in which case males, right? Now, if all respondents were female, then the average wage would be much lower than 1.75. In fact, we can measure that. Okay? So on average, let's try to run this line 11. On average, after controlling, assuming that experience is zero, assuming zero work experience, it just tells you that males. So this first line refers to the situation where all respondents are males. They earn an average of 1.75 log of which, so you can just exponentiate that. And when all respondents are female, the average wage would be at 1.35. So if you try to subtract this, the difference would be around negative 0.39. Okay. Now we can demonstrate that using a graph, right? So this graph, this line 13 to 16 shows a scatter plot of log of wage and experience, and it will show you the regression line. It will show you the estimated regression line using two different intercepts. One intercept will be for males, the other intercept would be for females, right? To reflect this difference. Okay. Right. So it's not really that obvious, but as you can see, this would be this gap between the two red lines. The gap between the two red lines will be the 0.39 that we just estimated. This difference. So the solid dashed line would be the average male wage and controlling for experience, and the solid line would be for males. The dashed line would be the average wage for females after controlling for experience. So you use dummy variables to indicate or to capture differences in the outcome variable across groups while controlling for other regressors. So that's the purpose of it being a shifter. The coefficient of the dummy variable represents the change in the constant or in the intercept between groups, right? Between groups of individuals in your sample. Okay. Now you can also use dummy variables as a slope changer, meaning we can interact a dummy variable with another regressor to indicate that the marginal effect of one regressor, in this case in line 21 that would be experienced, is different between two groups, right? So in this case, it's different. The marginal effect of experience differs between males and females. So let's try to run that regression. So these are the results. You still have your shifter variable, which is your dummy variable for female. So this indicates that after controlling for experience and its interaction with female dummy variable, uh, the average wage for females is still significantly lower. Experience is increasing at a positive, increasing wages at a positive rate. Okay. But of course, given this interaction term, so this is your interaction term. Given this interaction term, this means that this, and it's significant at 10%, it means that the marginal effect of experience depends on whether the respondent is male or female. Okay? So considering that this interaction term is significant and negative, it means that the marginal effect of experience is lower for females than it is for males. And we can see that by running margins command to see the exact effect of experience between these two groups. So you can just type margins, dy dx experience for both males and females. And so line 23 generates the marginal effect for, so you don't have to compute it manually. You can use margins to check the slope of experience or the coefficient estimate of experience between these two groups. Right. So for males, it's exactly identical with the estimate 0.0066, but once you take into consideration the sex or the gender of the respondent, it seems that the marginal effect of experience is lower for them, which is at 0.00073 or 74. Okay. So there is a clear difference between these. There's a clear difference between the two groups. Now, how do we demonstrate that graphically? Okay. So I'm going to use this couple of lines here from lines 28 to 34. Just captures the coefficient estimates. I'm picking up the coefficient estimates for female, for experience, and for the interaction term, as well as the constant, to plot the regression lines. Okay. So you can pause this video for a minute and try to examine closely what I'm trying to do here. So I'm getting the coefficient estimates. Right? I'm getting the coefficient estimates. I'm plotting them into a line, right, so that we can see the difference in two slopes. Maybe I can also include a scatter plot here just to be sure. So let me add it here. Okay. And let me just clean up the graph. And let me run this. Oops. Of course, we need the scalars. So run this. Sorry about that. Let me do this again. And that's your graph. So the red line represents the male average wage. The green line represents the regression line for females. So as you can see, it appears that males tend to earn higher wages on average given this gap between the two lines. And when it comes to experience, the effect is more prominent for males than it is for females, given that the line for males is a little steeper than the line for females. So this is how the interaction term works. It basically demonstrates the difference or the change in the marginal effect between the two groups, in which case we see that the marginal effect of experience for males is higher than it is for females. Right? So as you can see, the execution is really simple. Including a dummy variable in your regression model, it's pretty simple. You can use it as a shifter, you can use it as a slope changer, you can use it to indicate that there is a difference in the slope across groups, and you can also use it to indicate that there's a difference between two groups in terms of their average. Now, one reminder for everyone who's watching the video is when you use a dummy variable, make sure that the variable is indeed a dummy variable. So it must be an indicator variable. It could be 1, 0, 1, 2, 2, 3, 3, 4 discrete values, right? And there's no room for in-betweens when it comes to dummy variables, right? Because I have already encountered a case wherein this person argued that the dummy variable, the value of that dummy variable must be zero point 0.5 because, well, a certain policy was implemented in the middle of the year, and that is a big no-no because that's wrong, right? There can only be two values when you're talking about category. When you're talking about categorical or dummy variables, there can only be discrete values and nothing in between. Okay, it can all be a yes or a no. It could only be a female or male. It could only be an urban, rural, nothing in between. Right? And then again, the execution is fairly simple. And inclusion, of course, the inclusion of dummy variables in your model will, of course, depend on whatever the literature says or whatever conceptual framework demands. So you may want to look at this code again, review this code again, review the codes in the previous video, right? And try to practice for yourself. Thank you for watching.